So, come on. Good afternoon, everybody. So, my name is Thomas. I'm currently working as a threat researcher for a company called Digital Guardian. I've had 25 plus years in this domain. I used to be in IR, spent a number of years in IR positions for large corporations. I also, some of you might know me as I'm currently one of the directors for B-Sides London. So I've been on a horse for a number of years, probably over 10, of why we stopped doing endpoint security. Yes, we have antivirus. Yes, we have tools to do post-forensics. But we're not really doing endpoint security. We're not trying to be at the endpoint and gather intelligence, because there's a lot of intelligence to gather if you're in the right place. So I'm trying to re-enable that as a defensive mechanism more than just a post-attack mechanism or a post-attack thing. One of the things that I've been working on, and this is going to be a little bit of an explanation of what we're working on, is detecting via behavior. So we're moving completely away from the detection of an MD5 or a SHA or a footprint, but looking more at the behavior. So why am I on this kick? Well, if you think about the past, I think 20 years almost, a long time ago we decided to do this defense in depth stuff. The fact of the matter is we started building rings. The endpoint failed miserably because things got in the way, it stopped business processes, it didn't really work, it still doesn't really work, and businesses lost faith in the endpoint, and they're afraid to go back. So we've invested a lot of money in the perimeter, but the world has changed and our business has changed, and most of the critical assets are actually sitting at the endpoints. And you can define endpoint however you want: mobile phone, laptop, desktop, or even something like a server. So just why haven't walls worked? I think everybody knows this one, the Maginot Line. Well, it didn't work because it was incomplete and it didn't take into account the acceleration of the armament technology. But does anybody know this one? So that's Hadrian's Wall between England and Scotland. It wasn't built as a security mechanism, right? It wasn't built to keep the Scots out. The Scots would actually jump over the wall. The side effect was that when they were raping and pillaging, they had so much stuff to bring back they couldn't get back over the wall. Okay, so they were actually trapped inside the environment. Plus, the real purpose of this was to show the status of Rome, to show the status of the Roman Empire. And today, when we look at the technologies that we're putting into place to protect the perimeter, we're doing slightly the same thing. The more technology you put in the perimeter, the more the attackers are saying, oh, there must be some really nice assets behind that wall. But there's also the quote that I really like is, walls lost their effectiveness in 1545. Right? So that's from the physical part. I think from the IT part, we probably lost the effectiveness in the year 2000. It's Michael. Sorry. I can't figure out to raise it. It fell off from the back. Does that work better?
I think so.
Yeah? Okay.
Sorry.
Hopefully it won't move again. So, again, are we in the wrong place? We've been relying on network detection, and we're starting to put in, people have been putting in new network gen detection. And what are those things doing? They're just giving you another picture of the perimeter. The endpoint is still only seen really as a post-incident mechanism. Well, if you're in post-incident, you're already too late. If something's happened on your endpoint, data's exfiltrated, you've lost things. Something suspicious in your global logs, you activate endpoint resolution. Why can't we be more proactive and actually bring real-time endpoint detections back into play? So have you guys ever played on Windows with the Sysinternals Tools? Specifically, there's 3 tools that are really cool. So there's Process Explorer, Procmon, and TCP View. My favorite is actually Procmon. Procmon gives you a world of information of what's going on your system. So I was going to, if we can take a quick look at it. So this is Process Explorer for those who haven't seen it. Essentially, it gives you a view of what's running on your system, but it gives you actually more than that. You can actually drill into this view, and you can get additional information, like which process launched it, what time it was first launched. You can see what network it's doing, how much performance it's using, threads. So you can actually see what DLLs are loaded into the process. This is important because if you're being exploited, somebody's going to load a DLL into it. Yeah, Procmon is even more powerful, actually. Takes a bit of time to load because it's hooking into the... Come on. Yeah, demo effect. Where'd it go? If it loads. Doesn't want to load. No, it's running. It's just it's trying to. I think it's probably just trying to patch into this to gather the data to actually do the monitoring. Yeah, maybe I'll kill it and start it again. It's not going to work. There it is. So what does Procmon do? Well, Procmon hooks into the low-level APIs and actually tells you everything a process is doing. So you can see that even while you're running, basically Explorer, every time you open like an Explorer window or anything like that, it'll actually go out and read files that are at the current root directory, open up registry keys to read the values of certain registry keys to see what needs to be patched into the view. So there's all of this information. You can see every process running. There's also additional information, like you can actually get a historical process tree view. So if you run this and you've got a process that spawns off that does user authorization bypass, or it does escalation privileges, you'll actually be able to see the steps that it took to do those privileges. So even if the process kills itself in the background, the process image stays in this Procmon view. And you can see when a process will load a DLL, for example. So this is, it's a very powerful tool. The problem is it's a very noisy tool. As you can see, it's there's a lot of data being generated. We've been running it for less than a few minutes, and we've already got 150,000 events, right? And I'm not really running anything on this virtual machine. So once you start to understand this, you can actually start to build what we call application DNA. So we take those informational events and we can associate them together and track similar events over time. So that when you're hooking into the APIs at the right level, so if you're hooking into the file system, you can hook into file copy operations, file write operations, file read operations. You can start to build a picture of how an application is actually doing things. So you can associate a sequence of events. Typically what we'll look for is things like a file being read and a file being written. We can convert that into a label of file edit. If you see a file read and being written to a different location, it's either a save as or a move. Now, how do you determine whether it's a save as or a move? Well, you can track the rename as well, right? Because the rename will allow you to say, well, this file is being written by another process into a different name. So you can do things like capture when somebody's doing something like piping data into a new file, or you can use it to capture things like stenography. So if you're going to actually import a file into another file, you can actually see that because you'll see the file open for the file where you're going to hide your stenography, and you're going to see the file reads and then the file write into that open file. of different files in the same process. So we can start to build patterns, and we can start to build higher level events than that procmon actually does. So you get to see things like what you're seeing here, which is we can detect network operations, we can detect file writes, network operations we can elevate even further because we can tell based on if it's doing an operation and then starts downloading a stream of data, we're actually doing a network download. If you see a file read and then start to see streams of data being uploaded, you can determine a file upload. So this is kind of like a sysinternals, set of sysinternals on steroids. Right now, we're looking at file ops, network ops, registry operations, DLL activity, process data. There's a whole lot of data that we can collect. I've actually exploded databases with it. So what we're doing is we're looking at basically real-time forensics. So if you've worked in forensics, you know that typically when you have an incident, you're going to take an image of your machine, and then you're going to run your usual set of tools, case or whatever, or some of the SANS tools, and you're going to rebuild a profile of that incident. So you're going to run the memory, see which processes were running, see which DLLs were injected. Then you're going to have to parse the journals, the USN journals, to see what file writes and file reads were done, which files were deleted, which files were added. With tools like procmon or our tool, which is basically a super duper procmon, we can actually do that in real time. So we're actually detecting those events in real time. And we can log those, and we can basically log those and create a footprint and a real-time timeline of events that are happening. So I've got some concrete sample data here. So what we look at first is Chinese software. So I'm assuming some of you guys work for companies, you do business with China, you have Chinese employees, and the first thing those Chinese employees do is that, English isn't my first language, so I need a tool to help me understand English. So they install these tools. Those tools are actually really interesting because they aren't really input assistance and they aren't really translation assistance. Then I'll show you an example of Dridex. So I exploded Dridex in real time, and we logged a whole bunch of data on it. And then recently, we ran into a situation where we're running a tool for a customer. We're running a tool for a customer, and one of his users went to a site. It was a news site, and they got hit with the latest Flash 0 day. So we can actually see that what happens after that Flash 0 day basically escalates into the system. Oops. So the Chinese software. Essentially, what we're going to see here is this. So Sogu is one of the biggest Chinese software providers. They provide a set of tools that do a bunch of stuff. They're like the Google of China. They provide a drive. They provide online storage. They provide a wiki. They provide translation tools. They provide IM tools. And they provide endpoint solutions for their users, like Google does to a certain extent. But it's a lot worse than Google. You thought that Google was reading a lot of our data. This stuff reads even more. So this is the tool. Why we flagged it here is because it was spawned off Office. So the Office, the tool actually, when it installs a bunch of DLLs that hooks into Office. And you'd figure, okay, it installs a DLL, it's going to install a toolbar. No, it goes even further. It actually spawns off Office. So it launches a bunch of sub-processes off Office. And it actually launches SGTool, Sogu Cloud, and SigPic Face Tool. It's like, why, right? Okay, so fine. So these are to help you to type English and Chinese or to do translations. But the tool, as you can, what we see afterwards, is that the tool actually starts to ping out on the network. So if you follow this, so you see it starts actually communicating over the network. So first it's going to security profile, then it goes to check for updates. If it's got an update, it's actually going to install the update in the background. Then it goes and downloads a config. It's like, okay. But it doesn't stop there. It just keeps going on and on and on. So if you look at, we'll scroll down, and you see just all of these network operations happening in the background, and it just keeps talking and talking and talking. One of the issues we have with this is that, well, if you're running your Word document and you've got all these tools running in the background, if you actually don't know they're running in the background, what exactly is it sending back to China, specifically to Sogu? We're still working on that part, because it's we actually need to hook into the actual Word back-end data streams and see what it's actually picking up. But so one of the things that we can do is we can actually list all of these IP addresses and all of these DNS names, and we can start to actually query what they're actually trying to do. And it just goes on forever and ever and ever. It's like every second it's just pinging out to the network. So then Dridex. So this one's actually in reverse order. So here, I'm going to explain this a little bit more depth later, but basically this is a test user that's opened a. Is that still readable? Yeah. So what we see here is we see a file being copied off Outlook, and then Excel also copying that file. This is basically the spawning of a user double-clicking on an Excel file in Outlook. It starts to run a macro, which we see through this. This is the macro subsystem being loaded by Excel, and then it starts to do a network connection. So you see this network connection. We can get the DNS name. And I'm not sure if this one has the URL. No, this one doesn't have the URL. Sometimes we pick up the URL depending on the network operation. It should be up here, actually. There it is. So we actually get the URL. So you can actually go back and from this picture, either bar this URL, or you can actually go out and get the original file. Then you see Excel writing this file, and you see that it's actually become a file renamed, because the file originally was 5FG44, which you probably wouldn't see, which we wouldn't easily be able to detect if you were doing post forensics. And then you see this RubyOFE being written and started from Excel. From there, you actually start to see it doing some network connections. There it is. So the application starts, and then you actually see it pinging out to its command and control. And we've got the remote port here, but no URL, because this is just a TCP connect that it's doing. And it goes. I'm not sure if it went further on this test. Hold on a second. Yeah, no, it just keeps pinging out to the command and control was already dead at that time, so it just pings out keeps pinging out to the command and control. The W script is actually a different thing. W script this was actually a zip attachment with a Word file, with a JavaScript file that's called, to be precise, we can actually see, hopefully, if this picked it up. Oh no, it didn't pick it up. It's called like court notification _ 0546.010.doc.js. And when you look at the original email, it's like really well clarified that you basically ran a payment toll and a bridge, and now you've been notified to go to court. And a layman will open the zip, see the doc, won't see the .js because they'll have file extensions hidden. They'll double click on the doc, and they don't see anything happen, so they just give up. But what's actually happening is WScript runs in the background and goes out and pings out and goes out and downloads some stuff. So this also is in reverse order. Is it? Hold on a second. No, it's in the right order. So this is this was the customer that's testing this that ran into the latest Adobe Flash 0 day. So what happened was it isn't in here because there was I had to remove the line where we detect IE going out to a website and the link that it was going out to. There was some proxy information in it, and I didn't want to show it. But the next step is that we see a command shell running a batch command. When we look at the batch command, this is what it looks like up here, right? So let me zoom in. So in most cases, your network forensics boxes will pick this up, will pick this this obfuscated command line up. The thing is, it's not very useful for me because now I have to either try and run it in a virtual environment to see what it actually looks like, or I have to decrypt it myself, and I'm lazy. I got a whole bunch of other stuff to do. Well, to be honest, since we're capturing everything anyway, well, we might as well capture the original command line, the final command line. And that's what we're seeing up here. So if you look at it, basically, that bat file was actually running a WScript command, which is batch with a daf.js, which was downloaded as part of the Adobe 0 day. That second thing I strongly suspect is a password, and then you see it actually going out to this really weird URL and telling it that it's acting as an Internet Explorer. After that, what we see is that we actually see the network connection going out. So here we see the network connection. So we see the IP address, the domain name. That then writes a file and actually launches a bat from a temp file. So basically what it does, it writes a temp file, converts it to an exe, and launches it. So this happened to be, what it was downloading was a syshost malware variant. So when you're in the right place, this is the kind of data that you can get, right? Forensically, well, in terms of correlation, what the types of correlation you can do, and the amount of additional information you're going to bring to your overall footprint is incredible, because you're actually going to be able to build a real-time timeline. So if you add this information to what you're seeing in your firewalls or what you're seeing in your network events, you can actually correlate back to why did this happen? What process was actually responsible for this? It's one of the toughest parts is when you see network activity, you don't necessarily know from which process it was coming from, unless you actually do the full-blown investigation. So with all these events, what we started to see is that we actually started to see patterns forming. So when you open a file from Outlook, you're basically always seeing the same thing. Outlook saves since 2007. We've run this from Outlook 2007 all the way up to 2013. When you double-click on a file in Outlook, what it does is it copies it to temporary internet files, it saves it to temporary internet files, makes a copy of it, passes it on to Excel or Word. Word and Excel copies that into a temporary location as well. This has helped us actually determine a system of behavior. So we've raised our application DNA to a new level where we're saying basically, okay, so if this set of events happens, we can now categorically say that the user opened an attachment off Outlook, right? So once we start to do that, we can look at what's happening afterwards. So in a phishing attack, what we can see is we can actually start to build a behavior tree. So Outlook creates a temporary file. The file is either written to a new location or another process file opens it. What we can do too is if the user does a save as the file, there's this very similar process. The file gets temporarily saved into Internet Explorer, but then it will get saved into something like downloads or documents. So we can actually tag that file in memory and say, okay, if this file was saved off Outlook, then it's an attachment. So we track it as an attachment further down the line. That file is then opened, so we have an attachment open. There's nothing wrong with a user opening an attachment. We don't really care. We're probably going to throw away most of these events and say, no, this is just an attachment being opened. But then it loads a macro, or it loads the macro subsystem. This is where we start to get to an active attachment, what I'm calling an active attachment. That means the attachment isn't benign. That means it's doing something. It's no longer just a Word file. It's no longer just a PDF file. From that, we see that the Word process or Acrobat process or Excel process writes a file, or first does a network connection and then writes a file. So here we're starting to get into a little bit more serious domain because we're actually starting to see that the file that was once opened is now doing stuff, right? It's actually doing stuff in the background. Then that file gets moved to the user directory, right? So we're starting to look at, this is getting interesting because this isn't normal behavior for something that's happening for a user using Word. And by user directory, I mean things like app data, local app data, and company, right? Temp, things like that. Users won't usually save directly into those folders. They'll save into documents. So we can kind of raise the risk and start to look at saying we're monitoring a suspicious activity, right? So one thing you'll notice from this is that right now the processes outside of Outlook being the initial step, the rest of the processes that are launched behind Outlook could be anything. I'm not looking at specific footprint. I'm not looking at a specific MD5 or anything like that. I'm just looking at a set of activities that are happening at the endpoint. And I'm collecting the data as I go. Now, I move the file to the user directory, then, the process gets spawned off of Word or off of Outlook. So there, we've actually elevated that risk because that's just not normal behavior. We've seen a couple of instances where it is normal behavior. So if any of you guys are in finance, Thomson Reuters uses a macro system similar to this. So you can actually, the Thomson Reuters add-in for Excel actually does something similar to what we're seeing here because it'll actually do it'll download temporary DLLs for the queries that it's doing. There's software like that that's a bit weird. WebEx does the same thing. If you use WebEx a lot, you can actually see that WebEx is actually writing a stub application based for each of the sites that you go to. So, for example, if you go to deepset.webex.com, you'll actually end up with a stub application in the app data. So there's some processes that actually do this not naturally, but in the majority of the cases, it's not normal. So you're gonna be able to whitelist those few processes that are basically saying, okay, that's normal aspects. Whoops. So, how much time do I have left? So about 20 minutes left. How much time do I have left? About 20 minutes? 10, 15? 20? So I'll be able to do a quick demo if you guys want. So one of the things that we're doing is that we're collecting so much data, and we want to collect more data. We're collecting a lot of data. We've been feeding it back into SIMs. So we can correlate the endpoint data with the SIMs. So we start to, I mean, the example I usually give and explain and talk about is,
just a second.
Yeah. Nothing. This one's not working, right?
Kannst du es aufnehmen, dass er mit dem dabei sprechen kann? Also jetzt mal hochgehen, dass er mit dem sprechen kann und dann wird er den nutzen können.
Hello. Yeah. So if you've ever used SIM or seen SIM, Splunk rather, if you look at their ESM solution, right, the enterprise security module, they'll give you a nice picture timeline of all the events that are happening in your environment and all of the attacks that are happening in your environment. But it's all network focused. And when you look at the timeline, the actual timeline starts when they see it at the network. They never start beforehand. We started doing some tests with them where we're feeding back this data that we're generating, and we can actually build a complete timeline now. Because we're actually looking at going from the time that the endpoint actually ran something, giving them the data of what was run to that network connection, and then that network connection can be correlated back to the network events that you're seeing in the firewalls or in your IDSs. So the more data we capture, the more relevant information we can provide. Working? Hello? Yeah, okay. So the problem that we're having right now is that we can generate so much data we don't know what to do with it. Well, we don't know how to analyze it, to be precise. It becomes very difficult because you start to see things that are normal, so you'd want to whitelist them. You start to see things that are gray, so you don't know what they are yet, or you've never seen them before. Or you start, you have bad things. So one of the things that we're looking at doing right now is going to automated anomaly detection. Now, automated anomaly detection, to do that, we're bringing in machine learning, which is a lot more complex. So on this slide, you've got actually 3 graphs of what we're trying to attempt. Essentially, what you're seeing there are patterns of events that are happening on one machine. Some of them are user-focused, so the one bottom left. Some of them, and two of them are service-focused. And you'll see that the user-focused, there's a lot more activity. And what we do is we regroup the events into similar patterns. So if they come from the same process, if it's a normal timeline, if it's not, if it looks like it's supposed to happen. So if A plus B plus C equals D, right? So 1 plus 1 plus 1 equals 3. If we get 1 plus 1 equals 5, you start to get an anomaly. So that anomaly can be things like, oops. Sorry. My fingers are... Oh, come on. Okay, let's get this right. Okay. Sorry about that. So, like these stars down here, those are outliers, but they're not necessarily suspicious. So it's something that happened that's close to this green area, over here, but isn't necessarily suspicious. Well, isn't necessarily associated to that green area. So it becomes a slight outlier. You've got another one here. So These ones are a little bit more complex. So most of the system services we see are actually doing very similar things. Then every once in a while, you get a really big outlier. That's the red dot. Basically, what's happened there is that a service that hardly ever spawns or hardly ever starts goes into play. So you start to see events coming from that one activity that's only coming out every 30 days or every 15 days. We had a lot of trouble training this to do on Windows updates. Because, as you know, in September, Windows changed its update mechanism and they started doing not out-of-band patches. So we started to see Windows Update acting up, and we were flagging it straight away as abnormal because Windows Update wasn't supposed to run in the middle of the month or at the end of the month. So there's a lot of things that you can do with this much data, and that's where I'm coming back to my story, is that why aren't we doing this stuff at the endpoint? I've got answers for that, and unfortunately most of the enterprises don't want to hear it because it's always the business takes priority. Well, the business is killing you at the same time. So we need to think about, do we want to protect the business and protect the assets, or do we want to play with the users and say, well, the users don't want it because it gets in their way? To each his own. We got enough time to do a quick demo. So I'm sorry ahead of time. You will be seeing the product. I didn't want to do too much product stuff, but I'll leave Process Explorer running just so you can see what's running in the background. So these are actual. So these are actual phishing emails that I get on B-Sides London. Don't ask me why. People want to fish for B-Sides London. It's incredible. But there's nothing to gain. I don't know why. So this is so if you follow latest phishing campaigns, this is one of the latest ones, right? So a fake scan file from your printer, right? Or interfax service. So you get this scan as a zip file. So as a user, you think, well, okay, it's scan zip file. I mean, that's normal because they don't want to send a big scan file in my email, so they zip it up. So most users will have a view like this, and they might not recognize the icon. They just say, oh, it's a doc file. It's okay. My IT guy said I could open doc files. They double-click on the doc file. Oh, yeah, it's because it was downloaded. It opens up. Ignore this one. It's because... So, things are happening in the background. It's like, where's my file? It's not opening. Oh, well, I'm a user, so... I don't care. But I don't know if you notice Process Explorer in the background there. The activity that's going on. So this one's pretty active. It's going, it's going, it's going, it's going, it's going. So now we should be able to see. So here's stuff we're not seeing, right? So basically here we have that script that's being launched from the archive. And so we can actually see the original command line. So there, you remember I was telling you from that spreadsheet that this is where, I forgot to zoom in. So remember I was telling you how the command, was doing a W script on the JS file. So this is the original command line. So after the W script, you see that it does an outbound network connection. So here we have the DNS name, the IP address, the port, And you notice one thing is that, it's a port 80. It's doing a normal TCP connection on port 80. Most of your firewalls and proxies will let this through. And trust me, they do. I've seen it time and time again. Then you see it. So basically what it does is, so this is the alert. This is an alert view, so you don't actually see the forensics view. But you see it, running a process outside of app data local, temp. Right? So it's created a process, and it's actually ran it. And you see, this is stuff that, you would only be able to get if you actually did a full forensics dump of the machine after the fact, right? So I'm gathering this in real time. You see the process launch. I've got all the relevant stuff that I would use in forensics. I've ran this 3 times already today. I actually have VirusTotal API hooked into this. You'll notice that it's still not showing up as a VirusTotal MD5. That minus says there's no scan data. So basically I submitted the MD5 to VirusTotal, and VirusTotal's told me there's nothing there. So that means none of the AVs would capture this right now. And here you saw all the activity we were seeing. See, all of these are application launches, all of the different versions of the file. So even this one, the MD5, okay, so you got to hit 11 out of 55. But so depending on the rating that I put, I can put a check mark next to it or what. But that's another thing. Oh, wait, I didn't run no batch command. Oh no, that's my colleague. Never mind. We'll ignore that one. Let's see if it's done anything new. Not yet. So if I let it run, yeah, see, it's question mark. That means VirusTotal process unknown. But with this, I've basically detected abhorrent behavior on the system, right? I've detected a user opening a zip file, running a W script, and then that W script launching some executables doing a network connection and launching some executables off app data. So this is why, I strongly believe that we have enough power nowadays to put endpoint protection back into play. Not the traditional endpoint protection, but put something new, something that actually does detection, something that actually gives you intelligence. Because if you associate this to the rest of your intelligence, you have a much better picture of what's going on in your environment. That's it. Any questions?
We've got some time for questions. Yeah.
Thank you.
How far are you in detecting this automatically? What you have shown now?
It's working. That's what it works. So most of those alerts I can actually put into block mode. So because we're hooking into the same, actually lower level APIs that most antivirus vendors do, and the same places that most of these malwares want to hook into. So we hook into there first. So if the machine's infected already, we're a bit
so you can detect this where something is infected, is launched via Outlook, launches some PDF, gets some exploit and executes some binary. You can block that.
Where we're having trouble right now is the full gamut of detecting things coming out of Internet Explorer. Okay. So, for example, the Adobe Flash, we actually don't see Adobe Flash running because Adobe Flash does some interesting things to obfuscate itself from even Internet Explorer. And if Internet Explorer doesn't see it, we don't see it. Okay. So we're working on it. One of the things that I didn't have data on right now is the previous presentation was pen testing. So one of the things that we do is we actually detect all of the DLL injections and sideloads. So we can actually highlight DLL injections. So when you have a process that's trying to do DLL injections, we see that. Yeah. The DriedX one that I showed you, there's one variant that does UAC bypass by going into application, by inserting itself into the application compatibility database. I can actually see those registry changes being done in the application compatibility database engine being run, so that they can launch the second process, which takes over which becomes the proxy to capture the banking credentials. There's other things too. I mean, we can, because we're seeing all the file manipulations as well. Data exfiltration,
Yes.
right? Once that process starts touching data, we can highlight it. We've had some really good stuff with CryptoLocker. So we can actually detect processes that start doing massive file changes, and we highlight them as potentially CryptoLocker, or spawning off Explorer, service host spawning off Explorer. That's one of the other things that CryptoLocker does. So being that low, you can start detecting a lot more, and you can start seeing a lot better. I mean, that's the whole point of what we're trying to do is just being able to see better so that we can bring back the endpoint.
Mm-hmm. Questions from the audience?
What's the impact on the machine?
So what's the impact on the machine? The agent has actually been... So the agent that we're using has been around for 10 years. It's actually we're going into version 8 next year. Impact, we probably add an overhead of 5% to the machine. Memory footprint, we're about, I think, 3 megs right now, 3 to 5 megs. And physical disk space, we're at about 110 megs. The one advantage that we have is we don't have a massive database of MD5s. We don't use them.
So its footprint is smaller than a usual virus scanner, is it?
For pure event detection, yeah.
Yeah.
We've got add-ons that make it a lot more complex.
What do you do in this process to determine hostility or otherwise with the slew of call home posts that much software puts out? Many quite unnecessary and inexplicable. Are you just trying to say, well, if it does that every time, that's okay? Where do you get the trust from that?
So right now, we're essentially using a whitelisting mechanism. So if you want to detect and want to block those types of calls, we don't whitelist it. If you don't care, we whitelist it. That's why we're trying to go with machine learning. So basically to say, to aggregate a slew of Windows update, Windows call home stuff, and just say, well, this is a Windows call home, we'll just ignore it because that's what it normally does. We've actually, for example, the Sogo example that I showed, that just calls home it calls home even worse than Microsoft. And so what do? Do we sit there and block it, sit there, stop it? Some organizations will say yes, some organizations will say no, just ignore it. And that's the same problem. So there's a balance that we're trying to work on is how to actually prune out unnecessary events, which is a lot more difficult. And that's why we want to bring machine learning into play.
So would you go into the packet streams when
we don't need
home?
Packet streams, because if we're doing our job right, we're actually seeing the data being picked up first or being generated first, and before it's sent out over the network. So even with encrypted networks, right? So if they're using Tor or SSL, we're actually seeing the process manipulating the data before it goes into the tunnel.
So it's like you're looking for we'll have some of this. Oh, that looks nice.
Yeah.
Oh, that database. Wow. Yeah. It's that process which just is uncharacteristic of a program that you could focus on. Thanks.
Yeah.